Hi guys, so welcome to a new problem on LeetCode, so which is symmetric tree. So this particular question is being asked by multiple big companies, right? So you can see Amazon, Ada, and lot more companies actually. So what this question is all about? So given a root of a binary tree, right? So check whether it is mirror of itself, right? So if you look into this particular example, so this part is the mirror of this part, right? So that is what, right? So that is what this question is all about. So then it is known as symmetry. That means if any node is the left of this any particular root, then that should be the same node should be right of that particular root, right? So that is how means value is going to be equate, right? So if you look into the example 2, so you will understand, okay, so although this is fine, so left, so this is 2 and this is 2, but again these two are not mirror, right? So why? Because this is the right child, so ideally it should have been a left child in this particular tree, right? Instead of the right child, right? Or else the vice versa. If it is a right child, so then this is if this is a left child, so then this particular right child is okay, right? So that is all about the symmetric tree, right? So now the question is that how can we solve the problem, right? So basically what we are trying to do before thinking about the solution, what we are trying to do it here, and we'll do it is using recursion. So basically we are trying to compare two nodes, right? So and they are left and right child with one of the left and right child of other node, right? So whenever you are trying to check this particular left node of any particular child, let me take this example. So that should be the right child of some other node, right? So that is the idea. And whenever you are talking about the right child of this node, that should be the left child of this particular node, right? If I'm trying to compare at this level, and that will be done in recursively, right? So now the question is, what will be the, if we are planning to solve it using recursion? So what will be the base condition, right? So base condition should be pretty straightforward, right? So if both the nodes, right, so left and right, both are null, then we are okay. We can say that okay, we are happy, or we can return the true. If any one of these is null and other is null, so then in that case definitely we are going to return false. And if we are thinking about the values, right, so you must compare the values, so both the values must be same also. If at any point of time the values of the left subtree is not equal to right subtree, then there is no question of going forward, so you can just return false. Okay, so these are the things so that you need to consider about the base conditions, right? But how can you compare the, how can you compare or recursive call, how it is going to happen, right? So basically that is what we have already discussed. So right, so whenever you are comparing, so just try to call the recursively on the left subtree, and it should be same as the right subtree, right, or the right child, right? So of that particular thing, and the, if you are talking about the right subtree, right child, so then it should be equal to the right left child, right? So let me draw it here. So you must actually compare this particular left. Suppose you are at here, so if you are at here, so it's left's left, right? So if this is the child you are talking about, so left's left, so then it should be equal to right's right, right? So that is what it should be, right? So right's right, right? If you are talking about this node, so which is that child of left's right, right? So then it is going to be same as that of right child's left child, right? So like this one, right? So these guys should be equal and these guys should be equal, right? So that is what it should happen recursively for each and every node. So let's think about how to code it now, right? So let's go back to this, right? So let's start coding, right? So let's start coding, right? So let's start coding, right? Okay, so now the question is how to code it, right? So just let me, yeah, so how to code it, right? So how to code it, so basically what we will do, so we'll initially check that, okay, so if like my root is like null, right? So then immediately I can return, right? So immediately I can return, right? Immediately I can return, or else what we can do, we can call a magical recursive function, right? So which will return that, okay, whether the left and right subtree of this particular root is same or not, right? So let me write it down. If root equal to null, so this is the base condition. You can discuss with your like interviewer whether root can be null or not, but for this case we are just returning true. Okay, so then I will call that maybe, okay, is symmetric tree, right? Tree, then I will pass the root dot left and root dot right, right? So that is what I want to compare, right? Both the left and right subtree both are mirror to each other or not. So that's why I'm passing 2. Okay, and whatever the value it is going to return, so then I will simply return it, right? So yeah, I'll simply return this particular thing, right? Okay, now let's start writing this particular code, right? So this will be like maybe boolean, right? So boolean is symmetric tree. Okay, so let me just quickly write it. Tree node maybe left. So this is, I will name it as left child or left node, then tree node, sorry, yeah, so tree node right, right node, maybe let me write it right, left node, right node. Okay, okay, so this will be the signature of my recursive call method, right? So now the question is how to write, right? So like we discussed, right? So what do we need to do? So we need to immediately check, right? So if any one of them, if both are the null, so then we are good and we are well and good, right? So if like I can say left node equal to null and right node equal to null, then we can return true. There is no issue, right? We can return true. So if after this particular thing, so that means if one of them is null, right? So that means one is null and other is not null. That means there cannot be symmetric, right? So left, if left is null, so then right needs to be null, or right is null, both needs to be null, right? So if I'll write, so left node equal to null, right? Or right node equal to null. So this signifies that since both are not null, if any one of them is null, so this signifies that this is not a symmetric tree, right? I hope you are understanding it. So that's why I can return it false, right? So now I know that okay, both of them are not null. So that's where it will come down. So what I need to check, if both of them are not null, so then I can immediately check the value, right? So what I can do, so lift node dot val, that's if that is not equal to right node dot val, then immediately I can return also false, right? So once I know that okay, both of them are not null, then I can check the value and if I can return the false, right? So if they are not equal, right? So if they are equal, so then what I can do, I can recursively keep on searching for next alternate other numbers, right? Or other childs, right? So what I will do, so I will simply call on the, so like I will go back to this particular diagram. So I will call on the left's left, that should be equal to the right's right, right? So I hope that is making sense. So then return is symmetric, right? So then I will call left node dot left, right? So left node dot left, then that I will call on right node dot right? So these are the two nodes must be compared, right? So if you look into this example, 3 must be compared with these 3. So left's left should be compared with right's right? So that is what one comparison will go that way. That should not be it, right? So then again I should be also comparing. So which one, right? So again I should be comparing. So left node dot right? So then that I need to compare with which one? Right node's left, right? So right node dot left, right? Yeah, dot left. I think that is pretty much it, right? So that is all about this particular program. So let's start running this particular program and let's see if we are okay. And if you have any questions on this particular, just put it in the comment box so that we can discuss on that. Okay. So there is some error we can see. So which is saying that right node, you can see cannot find the right? So if you look into the data structure, so then it shows that right? So there is a, yeah. So if you look into this, so this is right node, then there is a right. Okay. So okay, so this is this should be dot. Okay, my bad, sorry about that. That should not be comma. Okay, now you can see. So it is accepted. So let me submit it and let's see if it is working fine. Okay. So in the meantime, so look into the time complexity. So we are basically running through each and every load once, right? So that's why the time complexity, you can see this is accepted now, right? So that's well and good. So that is for today. Thank you so much. We'll see you in the next class. Thank you.